Kit Miyamoto is CEO and president of Miyamoto International, a structural engineering and disaster risk management firm. He joins me now live from Los Angeles. Thanks so much for being here. So much to get to, and I will get to the issue of what possibly could have caused this. But for now, I was interested in the fact that the mayor of Miami-Dade, came out and said, look, along with those, those expert and very brave rescue workers that are on the scene right now, they are bringing in the expertise of people like you, structural engineers. Explain to us why that is so important if you intend to bring people out alive, people who may still be there and in fairly good shape.
Yeah, it's a site is, as you can imagine, unbelievably dangerous, risky, and also fragile conditions. And you can see a half-collapsed building basically on top of you. And you essentially try to get into the debris to get to the people, essentially. That's what they try to do. That's why they usually structural engineers attach to the urban search and rescue team to essentially reduce the risk for the rescuers, And I was in 2017 Mexico earthquake and doing similar things, and it was they do definitely need a structural engineering expertise to become safe. But Miami-Dade, the county, their urban search and rescue team is considered to be one of the best in the world. I think they're doing a great job out there.
The other thing that you've said is one of the best in the world are the building codes for this area of Miami. I know that you have been mulling this over with all of your expertise since this happened.
Yeah.
We're all wondering, what could have caused this catastrophic event?
Yeah. Well, this type of collapse we see often in earthquake countries. Our team and myself probably investigated over 500,000 buildings damaged in a collapse like this one. But you're talking about earthquakes, earthquake shakes and building collapse. But this is highly unusual because there's no tremor or there's no storm or nothing like going on, right? But the building system is actually pretty simple. It's essentially the series of this concrete plate. It's a floor, sits on top of the what we call columns, essentially pillars. They're spaced usually about the 10 meter each way, about 30 feet. And so if one of the so-called pillars fails, everything collapses on top of each other. That's exactly what happened there. And that most likely the column failed is somewhere in the center of the structure because that's where the failure was initiated. And as you can see it at the lower level columns, which is the collapse of first. That's how it actually worked like that. Now, question is why that column failed, right? No one really knew that quite yet. But technically speaking, you can kind of imagine there's a couple things could have happened to it. One very good potential is the corrosion. Each of the columns made of a reinforced concrete. There's a rebar inside, we call rebar, that's a steel reinforcement. That actually provides the integrity and the strength of the column itself. Because think about this column supporting a huge loading above there. So really strong. But once this gets compromised by the, especially the salt air, or water, it corrodes, it's rust. Once rust, then the steel lose the so-called capacity and become weaker, and also in many cases actually compromise the concrete around it because the rust expands and spoil the concrete and lose the capacity that causes a collapse.
Yeah, I mean, still so traumatic to think about. I know it's going to take many months to really get to that forensic level. We know exactly what happened. Yeah. Kit Miyamoto, thanks so much. Really appreciate your expertise on this.
Yeah, thanks so much.